rhizosphere, or more space around root systems, which is where a lot of those microbes are living and breathing and cycling nutrients. So this underwear is decomposed because of the microbes. It's important that you use cotton underwear when doing this test. So it's also a good opportunity to talk about fashion. And yeah, step right on up. And these are, so you can see those with your naked eye. You can see mites with the naked eye. The nematodes you have to have a microscope to see. Tardigrades, kids love to talk about those. A lot of rare. Not going to see any of those today. Typically water organisms.
Do you know exactly
amoeba.
which ones are
I don't know.
They're labeled on the microscope.
Oh,
okay.
Sporophores, these are really cool to look at in a microscope. And then flagellates,
Soil.
microalgae, fungi, and bacteria. And in this one is set up for 400 times the magnification. So in this one you can actually see bacteria, which just look like little dots.
So, how do you just maybe a description of like how you prepare a slide?
Yeah, so here's how, I'll just show you how to do it. So you take one of these, a slide, and then you take a cover slip. This is a cover slip, it's glass, so do be careful. You will cut yourself. So then you just, I like to put a little piece of paper underneath me so I see what I'm doing. In here, so this has been sitting on its side for a little while. I'm going to let it just sort of set again. What we do here is you take just a little piece from a soil aggregate, like maybe the size of your pinky fingernail, something like that, or smaller, and then put about 25 milliliters of water in, or about an inch.
Water's the only solvent? Like,
it's the only solvent,
okay.
and it's very important that it's non-chlorinated water. If it's chlorinated water, you will kill all of your organisms, and you won't see them. So non-chlorinated water, which we just took out of the sink here. And then you want to try and get your sample using a pipette. So you put
that supernate off the top.
Off the top. Ideally, you want to do it off the top. So first you put your sample in, then you put a little bit of water in, and then you just tap like this. You're not shaking, but you're tapping to sort of mix it, and then you let it settle a little bit, and then you want to take a drop from the top.
I guess we'll find out.
And it's really just a tiny drop,
And you can look.
like so. Put a drop on your slide, and then take your cover slip and put it right on top. And there is your sample. And we can go ahead and just look at that one. This is a well slide. So this was set up for bacteria. When you are adjusting a microscope, you always want to bring it down to your smallest ocular. Lower your stage. And so this is a well slide, meaning it's actually got a little divot where you can put water in it. And that can be really helpful when looking at certain organisms. So we just take this.
That doesn't have.
Correct. That's right.
So organisms will be.
Yes. Yes, they will.
What are we looking for?
This is actually really helpful to reference.
There is a reference here. Probably not going to see a whole lot of organisms through these. This isn't going really small enough.
Okay.
I think these only go to 20.
Might have seen a nematode in one.
You might have. Was it this one?
I can't remember now.
I did see
Yeah, that one, I
squigglies.
think,
I did see squigglies.
Do you want me to look through the boxes and find the longer lenses, or?
Oh, did they
these?
come with longer
Yeah.
lenses?
I think we had. We just put 2 because we didn't know which ones you wanted.
We don't need 100, but if you had a 40, I think we have 4, 10, and 20 on here. If you had a 40, then we could see bacteria. So,
These ones.
There's a 40 on this one.
oh, there is.
But, So this is what we changed. You know what I'm saying?
Oh,
So.
the top part.
Yeah.
And
so
what are
see,
those?
This one's smaller. Would you like the bigger ones?
Yeah, why don't you bring one over?
Okay.
This is a 10.
Okay. So I'll
So
grab 2.
10 times, yeah, so that would be 400. If you have a 40, you're looking at 400 there. So you want to bring your stage up first. making sure to not smash the thing.
Takes a finger. Oh, sorry.
You can adjust your light. This one has a light adjustment. And then it's all about getting it to your vision. The small one is your fine adjuster. The big one adjusts the stage itself.
So it's just the small outside.
That's right, just the small one. And you can, as you're turning the small dial, you will actually go through layers of the sample.
Oh, wow. Much better.
So go ahead and have a look. I have it focused to my eyes.
Talk about nodule.
You might
Move it
need
up
to
and down.
readjust it.
Oh wow.
Isn't that cool?
Yeah. So, and that's part of the reason why
And this one
the
right
clover that I planted in there, I don't think germinated because it wasn't inoculated to help it do its thing.
We're doing it that way.
Do these,
Yes, you can move them, yep, in or out. That's exactly right. I only use one of my eyes,
Yeah.
so I don't even bother. But this one just it's for show.
just pretend it works.
So a lot of what you're seeing in here are particles of soil, the shiny bits, the angular bits.
Yep.
I am seeing what looks like it could be a root hair. Root hairs are huge in the microscope.
Yep.
Well, there's definitely things that have a cell wall that are sort of on top of the particles of like little bits.
You can often see protozoa, different amoeba.
Situation here. Is one like a denser root system like these two? Well, to be honest, this is not a very fair comparison because I did not weigh my seeds out. I didn't do like, 120 pounds per acre in my pot. I was like, I'm just gonna do this quickly and throw them in there. But just to get a general idea of like what that can look like and why it might be important to have mixed cover crops so you have different types of rooted. I'm actually really surprised that these, like the peas go down so far. It's pretty neat.
And I used them to kill oocytes, like to look for parasites.
Parasites in the poop.
Yeah, myself also. There's this whole recipe for poop solution,
Oh, that's
So,
great.
yeah.
We at one of the schools I work at, we have goats, and we'll often slice goat poop.
Yeah,
and
right.
put that
Look
under the
for-
microscope. Yeah.
to look for eggs.
I think we have a few more minutes before we switch. Kat, sorry I was busy when we first started. I heard you talking about this, but I do have another poster, a couple posters to share with folks to kind of synthesize some of what you're seeing here, some of what you saw here. Because I think one of the big pieces is that, and Charles was talking about this earlier, right? Like the more roots we have, the longer we have living organic, like living roots in our soil, the more grow and thrive. You're seeing through the microscopes, right? And so this, when we're talking about microbial communities, this is a graph, or a couple of graphs showing the overall metabolic rate, so an account of how many microorganisms there are, an abundance of them. And the one on the right is saying, well, of all that abundance, how much diversity is there? And we ran this using EcoPlate, so this is very coarse. I can't tell you what the functional groups are of the diversity at all, just that there's more of different types. And so this is a long-term trial that we have up at Borderview Research Farm. And the things that there's a lot of different treatments or different types of management methods we have, but the ones that I want to draw your attention to are in this dark blue, the continuous corn, versus the perennial forage. So we have something that's annual till, no cover crop, just synthetic fertilizer as a utility amendment, and then a perennial forage. I think it's a fescue with alfalfa, and it's like 4 years old. Neither of these get any manure, so no organic additions through that. But what we can see is that in general, throughout the summer, throughout the growing season, May, June, July, and August, our forage has a higher microbial diversity than our continuous corn. And primarily that's because of the amount of roots that are there and the diversity of roots. And we see that mirrored over here when we're looking at the diversity. Again, we have higher amounts of diversity in our perennial forage than our continuous corn. So overall, like a little semi-Vanna White situation here. We're going to switch over. This is using those same treatments, same management methods, that we have an overall a higher soil health in our perennial forage. You can see us, there are beautiful rainbows here. In this scheme, our perennial forage is purple and our continuous corn is orange. So throughout a bunch of different soil health metrics, the perennial forage has higher active carbon. That's your more unsoluble carbon store versus soil respiration, which is what Heather was talking about earlier. It's more soluble, or it's a more respiration is more indicative of microbial activity. That's our 12:45. We should move on. Is that what the thing is?
So, yeah.
So I'll try to wrap this up. Our aggregate stability is higher in perennial forage than it is in the continuous corn. What I also think is interesting, I'm totally going into tangent here, is you can also see that the continuous corn, in terms of organic matter, active carbon, and they are not that similar, or they're similar in how they're performing to continuous corn with cover crop. So one thing that we didn't capture in this is what happens if you have cover crop continuous corn with no-till, because we get a synergistic effect with that. And with that, I'm going to just pause because I think we're supposed to switch over.
Thank you.
Yeah,
And
thanks
if you didn't
folks
get
for
a
coming
chance
in.
to see a soil aggregate yet, take a look because they're all over here.